Welcome to this talk about REST and HTTP. My name is Henrik Nielsen, and this presentation will be about showing you some of the technologies and ways of thinking about REST and HTTP and how to get started. When you skim the presentation, the agenda for this PDC, you will see that there's a lot of technologies that talk about exposing and consuming HTTP and REST. And you might think, well, what does that mean to me? How do I get started? How should I think about REST and HTTP? What does it mean? What are the technologies that I can use? And how can I get started? And the purpose of this presentation is threefold along those lines. One is to give an overview of what is the mindset, what is the mental model about REST and HTTP, how to think about it. The second is to give an overview over the technologies in .NET that you can use today to get started and how, and I will show you some of those. And lastly, we will actually go through some demos where we will see some of the technologies. We will see the technologies in a getting started kind of way. This will not be a deep dive into every single bell and whistle that you can imagine about the technologies. For that, there's a bunch of other presentations that I will direct you at later that will give you that opportunity. But this is a way for setting the mindset. Think of this presentation as a decoder ring, if you will, for the other side kind of presentations. And I'll try to remember, click this one. If there's one thing I want you to take away when thinking about REST and HTTP, then it is the notion of constrained interaction. Let me say that again, constrained interaction. What do we mean by that? Well, you know, just as what you have on the web, that resources identified by URIs, those are things that you see on buses and on socks and everywhere else in the universe these days. And that's the name that you give a resource. Without a URI for a resource, there is no resource. And without a resource, there is no URI. So the way that resources then behave is that they expose themselves in terms of state. That's the only way that they can communicate. The state exchange between resources is the only way that resources talk to one another. That's what I mean by constrained interaction. They don't do arbitrary operations on each other. They don't do method calls. They exchange state. And if you think of state as documents, that's a natural way to think of it, which is also what you get from HTTP and hypertext in particular, is that there are only so many ways you can modify and mock with a document. You can query it, you can get it, you can update it, you can insert stuff into it, you can delete stuff from it. But after sort of a 10-ish or so kind of things, you run out of things you can do. That's what it means by constrained interactions. You have a limited set of ways for interacting with the resources based around the state. But state, obviously by itself, if it was just static documents, would not be interesting. The whole purpose of REST and HTTP is to say, well, there's behavior behind the state. There's something that, in fact, changes, that gets kicked off when you interact with it through the state manipulation. That might be that you order a pizza. It might be you turn off a light bulb. It might be that you turn off a power station. The behavior is hidden behind the resource, but you can interact with it that way, and you can poke it, and you can see how, in fact, it is being manipulated. So one of the things that have been discussed a lot when you think about REST versus other mechanisms for interacting in distributed environments is that are these principles, these constrained interactions, are they guidelines that are useful, or are they a straitjacket that unnecessarily limits you in what you can do? Well, I think now what we're seeing is that there's a bunch of advantages and benefits that you get from going down this path that are generally very beneficial in distributed environments and when you write applications. One of the first and foremost is, and you have all been drilled this many times, obviously, you should write loosely coupled applications where one part can fail without the other parts failing too. It turns out to be hard to do that in practice. But the loose coupling between the state and the behavior in a resource gives you a very good starting path down that road. It's not guarantee to work in all cases, but it gives you a good start pad for going down that path. Obviously, scalability is one of the things we see on a regular basis. We see web farms where you can take the documents and you can put them out on many different front-end servers, and you can move the state around, and you can get a lot of scalability that way. Composability is one of the things that becomes increasingly important now that we start thinking about programmatic ways of manipulating REST services. The reason is that when you take a document and you take another document and you write a mashup of those two documents, you still end up with a document, a third document. But that third document you can still only operate on in the same simple ways that you could on the two sub-documents. So you can compose services out of each other and write mashups in a very natural way without having incrementally complex APIs that you have to carry forward all the time, because every time you collapse down to a resource, you collapse down to one document. Obviously, what we've seen is also that it gives you a great deal of interop and reuse, and that's one of the key aspects, that it is easy to consume, because the only thing that needs to be as part of the contract between the consumer and the producer is the shape of the document that you can operate and manipulate. And obviously what we've seen is that observability is another key aspect. Suddenly your web browser becomes a key aspect of your debugging mechanism, because you can go in and poke a system anywhere just by using its URIs for the various resources, and I'll show you how to drill down in that. And you can see what's going on in the system, which is tremendously useful in a lot of cases. But what we're now seeing is that the classic web-style application where you did HTTP GET and some posts in between is we're going beyond that. And that's when a lot of people sort of say, well, this is the REST model carried forward in a more extended way than what you do just with regular old HTTP. And for that, we kind of start using the rest of the vocabulary that HTTP has already defined in terms of get, put, post, delete options in order to insert, delete, manipulate data. But we're also using formats like Atom and extensions like Atom Pop to start dealing with collections and link relationships so that you can build complex graphs of resources and how they link with each other and how they interact. But, and there's this one thing here, is that we still, of course, have the post mechanism. So we're not going to say that just regular using XML over HTTP or JSON over HTTP is suddenly go away, because a large amount of services and resources and applications today are driven this way, and this is how we all do home banking and holiday shopping and whatnot, and we don't want that to go away. But in addition, what we're seeing is that there is a need to go beyond the simple ways that you can deal with link relationships. And this is why we're very happy to announce this Open Data Protocol, which is a new name for what was called the Astoria Protocol, which is a RESTful protocol for data sharing. But it allows you to do more complex URI-based querying, updates, and deal with hierarchies in a way that you can't do just with plain Atom and Atom Pop. So it kind of layers an additional layer on top of what you can do with those protocols and formats, and give you a rich way for interact with resources. And in fact, we will, later in this demo, we have Pablo Castro, who has been one of the key people behind this, coming up as a special guest and do a demo of what that actually looks like. So what is all this? This was about the what it is and why it is being useful. So now let's see to how it actually applies to .NET. We're now seeing that with these tools, with HTTP, with Atom Pop, with Open Data Protocol, we start seeing a move towards a programming model that spans HTTP at rest across all the tiers in an enterprise or in any application. We see this in the server side, where Azure obviously has been extremely influential in going down that path. And one of the things we see is that we want to have a unified way between thinking of cloud applications and on enterprise applications. And so we're seeing that even if you're just building enterprise applications, The cloud technologies that we use based on HTTP and REST will become part of that world too, because you want to be able to move applications smoothly between them. This is why it is coming across the board. It's not just in one area, and you will see broad spectrum of applications and technologies across .NET. When it's Azure is one. In the ASP.NET world, you have MVC. If you like the MVC pattern, which has been around for a long time and is now being codified as part of the ASP model, on top of that, there's some REST technologies that allows you to do content negotiation, other kind of things that can you can control the URIs for what the resources, how they should be exposed, and you can use that if that's what you would like to do. SharePoint 2010 has just come out with a new exciting set of REST functionalities around the Open Data Protocol that allows you to mash up, so to speak, resources that are stored on the SharePoint server, and you can interact with it programmatically using a variety of things. On the client side, you have obviously the browser, which has been with us for a long time, but you also have Silverlight when you want to drive the UI and drive a more finished kind of UI experience. And finally, now what we're seeing also is that you can get something like Excel Power Pivot that gives you very rich way for expressing and rendering these link relationships that are between resources. And so now, effectively, Excel is a way you can think of that as a tabular browser that allows you to interact and manipulate data in a very structured way using tables, because that is the key aspect that Excel brings to the table. So the unification is one of the key aspects why we see this broadly. But we also see that the guidelines that I went through earlier, in fact, are very applicable to a lot of scenarios that people write applications for in the enterprise, on the web itself, and anywhere in between. And so there are really two reasons, both that it actually are reasonable set of guidelines, plus the unification of the cloud and the enterprise. Finally, the big icon, the Microsoft.NET framework, is where we see a lot of technologies themselves now start exposing and consuming REST technologies, and that's where we will focus the next set of the next segment of this presentation around, where we will talk in particular about these things. And in fact, one of the things we saw is that there were a bunch of technologies that were kind of going down the same path, but were slightly different. And people asked, so when should I use this or when should I use that, and how do they kind of affect each other? And so what we're now announcing is that we're announcing an alignment around three technologies. We have first and foremost WCF REST. It was called that, what has been exposed as a WCF REST starter kit early on in a demo, in a preview, that allows you to build RESTful as well as just XML or JSON over HTTP resources with full control over the URI, the format, and the protocol that you want to use. Protocol in terms of what is whether you want to send redirects and that kind of stuff back. Then you have what was called the ADO.NET Data Services. Astoria was also a code name for that. That was using some of the same principles, but we're going for if you have data models, how can you expose those in a structured kind of turnkey manner? So what we're doing now is to integrate these two things, and we call it the WCF Data Services. It doesn't mean that the model will change dramatically if you've already gone down that path. It will still work, but you should now start thinking about, oh, I can now start mixing and matching the technologies between them, and that's where we will see in some of the demos later. The third technology that we're now bringing into the WCF family is the RIA services. They were traditionally called the .NET RIA services, which is about building rich end-to-end Silverlight applications that span multiple peers, where Silverlight is used as a presentation and data validation, and where you now can start seeing that these technologies are also brought into the REST HTTP space and be able to mix and match. In addition, of course, in the WCF service family, you already have traditional services, SOAP-based services, full flexibility for operation-centric services, and you have workflow services that allows you to build workflows using service technologies, and those are things that will, of course, still be there. So the way to think about this alignment is that you have the technology that's underneath for WCF. You have the channel model, you have the service model, and then on top of that you have a variety of programming models that give you ways for dealing with building REST technology and consuming REST and exposing REST services and resources. We have web HTTP services, we have data services, and we have RIA services. And now what we're going to do is that we will demo all those three segments and technologies individually, and then we will show a little bit about what we mean by this unification and show what we can do in a more mix and match setting. So the first thing is about the web HTTP services. And this is the most sort of the pedal to the metal kind of way of exposing the services. There's a most flexible way of doing things, but we will see how you can in fact start building these services and resources in a very simple manner. So let me try and flip over to this. Okay, so what we have now is a regular project where we want to start a new WCF REST service. Very basic stuff here. So we basically go in and say, let's create a new project. And as part of that project, we will use a new template that we're making available. And these templates will in fact be made available online, so you can download them dynamically. It is not that there, but I will let you know at the end when you can figure out when it is there and how you can use it. So in this particular case, it's just this new REST service. We click on it, and we have a new service which has a set of properties that are already going down the right path. One is, if you've written resource-oriented services before with WCF, you always have to deal with this .svc in the URI, which is kind of annoying because this is not really something that you want to deal with. So in this version, we fixed that. It's gone. And the reason why it's gone is that we're now using the ASP.NET route mechanism, where you register resources using the route table rather than using an HTTP handler. And so now we can in fact use the URIs exactly incorporating it into the ASP model without having to come up with the SVC for ASP to find us. The second thing you will see is that as part of the config, we have a very small config where here you can see we have the ASP.NET routing module. And now the only thing is that we actually say we have what we call a standard endpoint. And as part of that, we say by default you get help enabled, which means that there's automatically a help page generated for the resource that you have. And I'll show you that. And the second thing is that you have automatic format selection enabled, which allows you to do simple content negotiation between XML and JSON. And I'll show you how this works also. So just by using this template by itself, you actually get value in getting started. So let's just run this without doing anything else and see how it comes up. There you go. So we just say, we call this service 1. Go in here, and that's what you see. And if you go back and see, in fact, what is happening in here in the service 1, that one, is that we just hit in the get collection, which gives a collection that has ID1 string value hello. Now, the other handlers throw an exception, so they're not actually enabled. You, of course, have to fill them in. But what we can now do is we can say, well, let's go back and play with this just a little bit in Fiddler, where we can see that we now actually have the request coming in here. And so what I can do is, I said, well, we could do content negotiation. So let's take this request, put it into the request builder. And can you see this? So if you go here, you can see that we have the accept headers that HTTP sends. Now, the accept headers allows us to say what format we would like to do. This is the standard IE set of accept headers. But now if we say, well, let's just do JSON and submit that request again. We now go down and see what we have. And in fact, now you can see that you got the format out in JSON. Up here, you saw that you got it out in XML. So very simple ways. You don't have to think about JSON versus XML. It's already been taken care of for you. Another thing that you can do is that you can go back here and say, let's look at the help page, where you get this automatically generated help page that tells you, say, well, oh, I can do get. We now know that. You can do post, and you could do get with an ID, post, put, and delete with an ID to get a particular entry as part of this collection, put, which means create a new one or update an existing one or delete an existing one. So that's what you get out of the box. So let's now go back here and see what we have in another resource that is based exactly on this template. It uses exactly the same template, but I filled in a couple of things. I filled in, rather than the state, I filled in a person class. And you can see this is the state. So the resource is a collection of this person class. And you can see there's no data contract and data member attributes on this. This is just a regular C# kind of class. And this will serialize just fine without any of the additional attributes, which I always like because then you don't have to write all these things. So here now we have this service. And we have set it so that we get instantiated. We have some state here. We can see we get instantiated. We then have the get collection, which just returns the state. And let's try and just get this, see what we actually do here. Right? So we fire this up. We now go in here. We can see the service is being instantiated. And we now have the state coming back. Now, there's a couple of other things that I can do. Is I can say, well, in this case, this is all fine. But let's now add some handlers where we can do a little bit more. So I can do a query. I can say, well, let's get the element based on the name. And I have a little link query that picks out what it is. And if it doesn't work, I get a not found. I have a put entry where I can say, well, I have a method that says put, and the name is whatever it is, and now it means that if it exists, I will update it. If it doesn't exist, I will create it. So here I won't actually return a 404. I will always create a new one or update one. I then have a post where I can say, I have a post where I can just update the age of the person. And this is how I can basically get that. I get the stage, and then I set based on the parameter that I get in. And if it doesn't exist, I can do not found. So let's now see this. I built some very simple kind of get, put, post handlers and see how they work. So we go in here. That's not the one, that one. So now we have this. So now I should be able to say, well, if I do Henrik here, I get hit in my query, and I can see that I get this value back again. Now let's go back in Fiddler and get this data again. I get back in the query. And now I should have it over here in Fiddler. In fact, I do. And here, so I throw it into the request builder. Again, I can say, let's say, accept JSON, because it's slightly less verbose. I can create that and get in there. And in my Fiddler here, I can now see that I have my value here. Now, we also added a put. So why don't we just take this value and go up here in a request builder, change this to a put, which means update. Change this because this is now the content type text JSON. Add this, which is now the value, and say, let's just set the value to 50 and my way to say 10. And I should be able to put this and I get called in my put handler. And that was funny. Let me try that again. It works. OK, thank you. So now what we can do is to say, well, that's all fine and dandy, but I want to set the value to post. So I want to say just update the value. So I can say value equals, say, 100. And now I don't have a content length. I don't have a content type. And I don't have a request body. And I can execute that. And that's the one that I think it restarted. That's why it's funny. Anyway, you got to trust me on that one. You can do the post also. So what now is happening is that you've seen how you can have a basic REST template. You can get some stuff going with help. You can get some stuff going with content negotiation and URIs. And now what you have, in addition, is that you can very easily write get, put, post handlers that, in fact, perform in a consistent manner. And so let's just go back to where we are here, where the next demo, and here I would like to invite up Pablo Castro to show how you now can go at it from the other side of the things, where you say, let's start out with some data in a database and expose that in a consistent manner. Here you go.
Thanks, Henrik. Hi, everybody. So as Henrik said, there is the case where you actually know what your data looks like already. In many cases, if you look at the services that exist out there, they have very particular shapes, very particular purposes, and so you need to control every single detail of them. On the other hand, oftentimes what you have is a data set, not quite a database, but some piece of information in a database or somewhere else that you want to expose using a RESTful interface. Doing that element by element is a lot of work. And it's error prone because you have to do a lot of item by item thing. And it may lead to inconsistencies because there is so much code supporting more or less the same uniform interface across a bunch of resources. So the data services framework, which we shipped as part of .NET, allows you to create REST heads on top of data models in a way that is pretty straightforward and is entirely declarative. So you tell us what your model looks like, we'll create a REST head on top. So let me show you what that looks like. What I have here is Visual Studio 2010, and I just created a Bootstrap application. It's just the default MVC app, nothing interesting there. And what I did is I added a little database that I'm going to use. In this example, I'll use a database. You can use the framework to get data from other things in addition to databases. As Henrik mentioned before, for example, SharePoint 2010 actually uses the same framework I'm using here to expose SharePoint data. So first thing I need to do is I need to get data from somewhere. The somewhere for this example is going to be an entity framework data model. So I'll call this thing bikes, which is the name of my database. This is like a bikes shop, so I have my product catalog and my customers and so on. I'll tell the system that I want to create something from a database, leave the one I have there. Default name sounds good. And so now the entity framework, and this is, by the way, standard entity framework stuff, has nothing to do with Astoria or the REST interface. This is allowing me to derive a model out of my database schema. So now I will choose the slice of the database I want for my model. In this case, I only want categories and products, so I'll choose these two. I'll disable this guy for now and click Finish. So now what the EF does is it looks at the schema, takes the subset I selected and projects the model on top of that. And the entity framework has a mapping layer, so this is one of several ways you can use to customize the projection of, in this case, a database into a REST head. You don't really want to layer the database. What you want is an appropriate service interface here. So, I have my subset here. I'll remove, there is a photo ID, it's kind of weird. I'll remove it. There is also a details ID, weird too, so I'll remove it as well. So, and the mapping engine will take care of mapping this back and forth to the database. And great, I have a model now. So next thing I need to do is I'm going to create a data service. The way I do that is I'm going to go here and choose AD.NET Data Service. You can expect the template to get updated in the next round. It's going to be WCF. And I'm going to call this guy bikes. which is the name of my service now. So the way the template works is we give you a starting point, and the first thing you need to tell us is, this is a data service over what? Where do we get the data from? Oops, I want to do that. So I'll remove this template, this comment, and here you put a class that represents the entry point into your data set. This could be, in this case, an entity framework class. It could be some custom class you created that has pointers to your data tables and so on. So we have this thing called bytes to entities. It gets code generated by the entity framework, so I can hook it up right in. So by default, we lock down the service, so nothing is exposed. You need to tell us which set you want us to expose. So for example, here I know I have a categories set, and I'll tell the system that I want to be able to do everything, and I have a products set. And finally, if I run the service like this, it actually will work. Now, the one thing I want to do is, as I mentioned before, I don't want to just expose the data in the database. I want to control not only the shape, but also who gets access to what. So you can imagine sophisticated rules. I'm going to create a very simple one here, and for that, I'll use query interceptors. So interceptors are like a way of representing business logic that fits well with the nature of RESTful interfaces. As Henrik mentioned before, Henrik interfaces are constrained by design. Like you want a uniform interface across all services. So you don't have custom methods. What you have is behavior attached to the default interface, to the default methods. So I need to do this not by creating custom methods, but by telling the system how to react to specific actions. So I'm going to attach, in this case, a query interceptor to category. The syntax of this is kind of weird, but over time you get used to it, and then you think it's, pretty quickly you think it's the normal thing, but then you talk to other people and realize it's not. But it does go away over time. So this is a function that goes from categories to Boolean, and this is literally a predicate. You tell us which of the category objects, in this case, you want us to show. So I'm going to call this on query categories. And so in this case, I'll define very simple criteria. Categories are public or private. So what I'll say is, I want to know if you are an anonymous user. So I'll go HTTP context.current.user identity is authenticated. And now my criteria will be, given a category, either the category is public or you need to be authenticated. And we'll take this and actually merge it as part of the query we are formulating, push the whole thing to the database. So this is actually very efficient. It gets evaluated in the database, and no extra data gets shipped out of the store into the next tier app. You can do a similar thing for updates. So you push something and you turn on a light bulb, or you kick off your pizza delivery or whatever. OK, so at this point, I can actually run this guy. And using the same pokeability principle Henrik mentioned before, I can actually just mess around with it using my web browser. So I'll just hit the root of the service. And by default, these systems implement like most of all data just with almost no action from you. You can turn on and off different features. So at the root, I get an Atom service document that has the links to all of my sets. And I can do simple things like I can say /products. And basically, I'll get a feed with all of my products where each Atom entry is a particular product resource. And you can do get, put, post, delete, all those things on each one of the products. We also do things that are natural in Atom. Like, for example, we support linking things together. Every item, of course, has a unique URL. So I'll pick one of them. Now you can see this is not a feed anymore. It's an item. And you can see that there's links to relationships. In this case, for example, there is a link that says this particular category is related to a collection of products. So if I follow that link, this is another feed that contains a set of products. This is the first of them. This is like some random test. Let's take a better one. Like this one is one of the products within the category, whatever I chose. So we get a very simple interface with a whole URL namespace with conventions, and all of it is compliant with the OData protocol. So the last two things I wanted to show before wrapping up is, one is let's take on a particular product. I'll just say 772 here. So here's the Atom representation of that. I don't know what that was. If I paste the same thing in Fiddler, which is our friendly HTTP debugger, I'll get the XML just like I got before. As Henrik mentioned, there is content type negotiation built into HTTP, where I can say, well, actually, give me JSON instead. And automatically I get a JSON rendering of the same thing, and this works in and out. So whatever you can get, you can then reshuffle a little bit and push back in with a put or a post or a delete. So finally, you can imagine how to use this as a developer. You write some code on the client, hit the thing, parse it. So we also, as part of the Open Data Protocol, we enable clients that out of the box can talk to these systems. So what I have here is Excel 2010, and I have the Power Pivot plugin. Power Pivot is a new feature that enables information workers to retrieve data from multiple data sources and then do business intelligence on top of that. Of course, we can bring data from databases. We're kind of in the SQL Server team. It would be weird if we don't. But the thing is, most data is not directly accessible through a database. And even if you could, you don't want to bypass the business logic. So you can now say, well, I want data from any data feed out there. So if I take here the service I just built, and I simply point Power Pivot to it, we can go inspect the service, figure out the collections using simply the Atom service document, and say, here's the ones you have. So I can say, well, give me products, click Finish, and this will import the products into Power Pivot and show them in a table where I can manipulate them, create a pivot table, create charts, and so on. So as an end user with no coding, I can also access the same information that I could access as a developer and even mash up multiple data sources. As a developer, whenever I expose my data as the Open Data Protocol in the middle tier, I get all of these clients, both for developers and clients that can be used straight up by information workers to interact with my data and sort of get more value out of my systems.
Great, thank you. So I wouldn't let this go. To just show you that I still knew what I actually was doing here in the demo before in the post. The reason that I actually didn't formulate my request correctly. So it was a content type that I had in. But now I should actually be able to say, well, I hit the execute on the post. I get over here, and I get my value back. And if I go over here, I can now see that, in fact, I set my value to 20 again, which is a wish that I have, but that's not quite true. So there you go. Next demo that we're going to show is the third part of this trio of technologies, which is the RIA services. And this demo, you saw that in Scott Guthrie's keynote earlier today. It has a lot of very fancy Silverlight that jumps up and moves around and all that kind of stuff. The way I want to show it now is not to go into the Silverlight aspect of things, but to show you more what is it, how do I get going with JavaScript and HTML, and how can I access it through HTTP in a way that allows me to get going from any kind of browser. And so what I'm going to show you is, while that's just loading, is a different, so to speak, a view into that same demo. So here, in the RIA services, we now have the contact service, and it's still just loading a little bit, where we have the get stores, search stores, and update contact ways for dealing with data. And I, in fact, can run this, and it will show up in Silverlight if it all works out as I have planned. And as you see, my laptop is not quite as fast as Scott's. That's what you get when you become VP. So there you go. Let's just limit the size here a little. So that's the data that you saw as part of the, just because it times out, that you saw in the demo with Scott. But now let's go to a more, what I call, minimalistic UI. The minimalistic UI is just a regular HTML page where I have a query and an update button. The query just does a get on a particular URI of the service, and the post does an update that that can change the way, for example, in this particular case, it changes the sales target for a contact. So over here now in the Silverlight, we can see that this guy, the poor demo guy that I'm using, has a sales target of this particular thing. So let's copy that, take the same URI, change it back to page, and as I said, this is a more minimalistic UI. This is the extent my UI skills actually can go. So if I do the query, I will do a query against the data, and you can see this is not actually an error. This is the JSON representation of the data that was rendered in Silverlight. And it's just from plain old HTML. I can now also say that I can update the data, and so if you go back here and see what the data looks like, it says 9510. I should be able to do now update. I get called in my update handler, and I get a successful result back from the service. So if I go back here now and start reloading this, well, I set it to the same thing, but in fact, it was updated. So, oh, you don't believe me, huh? Let's try this one then. Jeez. Let's try this one. And go back here. Well, there you go. Very good. So now you're seeing the three kind of technologies in different ways for how to, in fact, get up and started with REST services. You saw the WCF Web HTTP services that allows you to build RESTful services. You have WCF data services that Pablo talked about for exposing kind of turnkey database access in rich ways. And you have the WCF RIA services that are driven towards building rich Silverlight applications, but in fact, you can also access them from plain old script. So these are things that you can do today. These are things that effectively allow you to get started with these things. But there's a couple of things that we haven't talked about. And so I want to go over and see a little bit more about some of the slightly futuristic things. They're not super futuristic because they were coming down pretty soon. But we'll show you, and this is why we have this, the blue background means that it's a slightly more exciting stuff in the future, that we want to be able to mix these services you saw for the data services and for the RIA services and for WCF REST. For example, one of the things you can do today is to expose a RIA service through the Astoria Open Data Protocol. And so the reason that matters is that I had to use the JScript to, in fact, interact with it. But wouldn't it be nice if I could build an application that used the, on one hand, the Silverlight user experience for sort of rendering, but the other side I could also talk to it using the Open Data Protocol. And so what we have here, let me switch back, is a mix that is just sitting on my laptop for now. It is a sort of bytes that are not fully baked, but we expect that they will come out pretty soon. And here you have a domain service that is the core piece of a RIA service. You have some person where you have a name and you have some events, titles, event date, that kind of stuff. And then you have the domain service that you created. This is just an in-memory kind of model. We create a set of persons and events and just fill them in with some stuff. You now have get persons, get events. Get time is an interesting thing because that's just really a plain old service operation that is not particularly REST-ish. It just allows you to, in fact, get mix and match the kind of mechanisms. You also have update, delete, and those kind of things. And then at the end here, you now see we're adding a WCF data services head on it so that you now have a mix of the two. You can start accessing these. And so let's see how these, in fact, run by starting this page in a web browser. And this is the description of the domain service that I get. And if you don't believe me, in fact, it has a WSDL description that goes on and on and on and on. And you will see that, in fact, somewhere down here, there is a get time operation that you can now start calling using regular tools. But more importantly, from this perspective, is that you can now say, let's do this thing where I now get exactly the same format which Pablo represented from the data service point of view now on top of a real service. So now you can in fact start mixing and matching these things. And in fact, you can take this and load it into Power Pivot also, and you can get exactly the same experience. So that's where we are with the next steps, where we're trying to integrate these things better so that you can mix and match as you wish. Now, one of the things that we haven't talked about today, and this is going to be the last demo segment, is the client side. We use Fiddler, but obviously Fiddler is not something that you want everybody to use. And you use HTML pages which use JavaScript and whatnot. And that's all fine. But in a lot of cases, you want to have programmatic access to the resources. And here we've been working on a new API for HTTP that allows you to access resources in a very simple manner. It was snuck into the WCF REST starter kit as called HTTP client. And we now have continued working on that. And that's the next kind of close future kind of thing that I want to show for what are the kind of APIs you can think about when you want to build and consume services and resources in from using HTTP and REST. So in this particular case, let's go back to demo case, is where we have it loading. And I have a couple of demos here that I want to tell you. First is a Twitter client, because everybody has to have a Twitter client. And the way we have done it here is that we want to be able to get the statuses of our friends. And so if we just load this, we'll now, from Twitter, we'll see we get a bunch of XML back that talks about the tweets that this particular account is monitoring. So here's what we do when we actually want to access this programmatically. First is what we're saying is that we create a new HTTP client with the base URI that we want to access. Then we set the credentials to this very secret thing, and try not to go crazy with it. I will change it soon. And then we start saying, well, now we want to actually do on the client, do a get on the friends HTML, which when you take that relative to this, comes up to the entire URI. You could also mix and match in other ways, but it's just to say that if you're submitting multiple requests, you can do relative URIs, which is what you would expect. So you get a response, you can ensure that it's successful, and in this particular case, the very first thing we do is that we just read it as a string and print it to write line. This seems all very mundane, but let's just see that in fact it works. And it should be coming up. There you go. And I'm sure that you have noticed that, in fact, this is exactly the same XML that I showed you before over here, right? So this is all fine, but let's try and do some middling with this so that we actually can get a slightly more readable presentation out of this. So we turn off the read as string, and instead what we do now is that we read as XML reader. When we load it into an XML reader, and we now use some links to basically say, well, let's pick out the status and the name of all the contacts that we are monitoring, and then be able to print it out this way. And so I can just operate on it as a regular document. So let's try and see what this actually looks like. This should be slightly more readable. And waiting for the network, and there you go. So you can see there's been a variety of tweets to this particular thing. Now, this is all fine, but what we would really like to do is to be able to, in fact, update and send a new tweet to this particular thing. So what we do is that we have an updated status, which is just the current time, this is all I have the imagination to tweet. And now we say, well, let's create a URL encoded form where we say the status isn't indeed the updated status that we just generated up here. Then we say, using the same mechanism before, but instead of saying client.get, we say client.post. We post it to the update XML, which is still relative to the statuses URL that we had before. And we now create an HTTP content, which is encapsulating the body that goes in the request. And we send that. And if we get a success, we say succeeded. So in this particular case, we should now first get this tweet, get all the tweets, and then we will submit another tweet to it. It's the network that is slightly slow here. So in fact, here we had updating status, current time, and it succeeded. So if you go back up here and just follow it there, we can see that this is in fact the state of where we are now. So thank you. So a new HTTP API. But in addition, what we've been working on is we added this to Silverlight, so now you can run it inside Silverlight. And in addition to that, we have come up with some helpers that help you do, because this was very simple, doing a single get and then synchronously actually, and then do some stuff when you're done. Now in Silverlight, you have this additional constraint that everything has to be asynchronous, because you don't want to block the UI, because then the user gets annoyed, and you want to have it, and that's kind of say, well, there's some of the things we want to be able to do here that are very common. One of them, let me show you the first one, is what we call get multiple, or send multiple requests. I have a set of requests, say 5, 6, 7, 8, 9, 10, however many you want. They might be get, put, post, we don't care. You hand them all to us, and we will submit them all asynchronously under the covers. Then we will, in fact, download all the responses asynchronously, all the covers. And when it's all done, we will have a set of failures and success cases back. We will call you back on the right UI thread, and you can then leisurely go through and pick and choose whatever you want to do from the responses without having to do anything else. So let's see how this actually looks like. Here we have a set of search templates. These are just going to dig.com, and the reason why we're using that is that that allows us to access it from any domain in Silverlight. So we have some queries we can ask for stories and topics, and then we actually fill in the query based on my fancy UI that you will see in a minute. Now, the bottom we say here is that if we get a query from the UI, we go through and create all the sites. And all the sites by filling in the query. And then we basically say send multiple async with the set of URIs. In this particular case, when they all get, you can just give us the URIs. And when they're all done, we call dig service downloaded complete, which is this particular handler. And now I can basically go through all the responses one by one and see where if they're successful, I can then read them as X element, whatever else, without blocking any stuff on the network. So let's try and see what that looks like. So here's just a jumping off site, so we have the dig sample. So in fact, let me just show you here what's happening by going back into Fiddler, and then go through here so we can see what's going on. So now we have this particular thing. So now I can search for something. So let's just search for, say, well, why not? And you can see that over here, you actually had these requests going out asynchronously, and we just gather them all, read them all, and when you're done, we call you in the rendering, and then you can render all the icons. The icons are the follow-up URIs that we just access afterwards. But here you see completely asynchronous mechanism for doing that as a helper. You can also say, well, it says search for Henrik, and you can see, I'm surprised, I'm shocked that there are no topics for Henrik. So this is why we get back a 404, but obviously we deal with all of it. We just gather it back and hand it back to you when it's done. So that's one of the helper libraries, the helper handlers that we have done, that we added. I'm just going to show you one more, which is a polling, where something you can say, let me just access this resource every so often, using either a get or put or post or whatever you want to do. And again, you want to do this all asynchronously, and I want to get called once you have kind of done the whole thing. So in this particular case, we have a polling sample. We have a subscribe button, and the subscribe then basically say, well, let's do poll async. And here we have the relative URI of the resource that is just a local one that happens to get current time. And we poll it every 3 seconds. And we poll it forever. If you want to say, just do it 5 times, you can say 5, and then it stops automatically after 5 times. Then when you have poll download completed, we will call this one, and there you can again read a string, you can do whatever you want to do, and see how that goes. And so let's just try and see how that runs. Again, we have my fancy URI here, and we have the subscribe button. And so we said 3 seconds, so if we count, I have to say something for 3 seconds, and there we have the URI coming up, and then we say 3 seconds later, and we have 3 seconds later again. And again, you don't have to worry about getting back on the right UI thread, having to deal with asynchronous, whatever else, we deal with all this for you, and we call you on the right thread. And I can unsubscribe if I want to. Fancy. So those are the two technologies. The first were the mixing, if you will, of the data services, the RIA services, and the .cf REST services in a way that allows you to start mixing and matching. And one of the specific cases is that you can use the Open Data Protocol, OData, on a RIA service. Then we saw some HTTP client stuff that allows you to access things in very easy manner for both synchronous and asynchronous on desktop and on Silverlight for how to access resources and interact with them. So where do we go from here? Well, hopefully you should now have a little picture about what REST is, that it is an architectural style for state-driven applications. State-driven is how services interact. When they get some state, they do some stuff, they send state to other parties, and that's how they interact with each other. Key is constrained interactions. They only interact this particular way. We've seen why REST is getting traction. It is interop between the cloud, on-premise, and cross-domains. And it allows you to move towards a resource-based application model that has a set of good and guidelines and principles that helps you down the path of building loosely coupled applications. So how do you get started? The easiest way is to download the .NET 4.0 Beta 2 and Silverlight 4.0 Preview that have just been announced and are out now. And in fact, all the 3 first segments of the demo stuff using the .cf REST HTTP services, the data services, and the RIA services, you can all go home and do today. It all works. Now, for the additional services and the mixing, and for the HTTP client stuff, we will announce this when it gets ready on the endpoint blog. And the endpoint blog we will also use to start sending out some more patterns and some descriptions about what REST and HTTP and how it might affect things. And that's where we are. Well, you should subscribe to that blog. Finally, there's a set of presentations that go more deeply into these technologies, and I know that some of these have already happened, but I would encourage you then to go and see them over the video so that you can see that these presentations actually give you more in-depth of each of the individual technologies, but now you have a decoder ring to go about and thinking about those. And that's all I had to say. Thank you to Pablo.